Okay, so I'm going to present Quickstrom today, which is a new tool that I've been working on for specifying and testing web applications. So yeah, Quickstrom is about autonomous browser testing, and it's based on specifications, as opposed to doing browser testing with examples or end-to-end scenarios in which you kind of describe explicitly, take this step, then take this step, do that, and then expect something. So instead you have these like general specifications of what are valid behavior of a system, much like you have properties in property-based testing, if that's something that you've heard of. Then Quickstrom, the tool, explores your web application for you and finds behaviors that are invalid, if there are any. It might find those. And it does this by basically interacting with the web browser and figuring out what's possible to do. And it can test basically anything that renders to the DOM, and the DOM is the document object model of the browser, which is essentially a tree structure that describes the state of a web page. Right, and today I'm gonna go through a bit of the background of this project, how it started, and the ideas. And I'll present the a case study called the TodoMVC Showdown, which I've sort of used as a benchmark of this tool itself. And then we'll go into more detail and look at the specification language and how you use Quickstrom to check web applications in practice. And then finally, I'll talk a bit about what might happen in the future, some plans I have and ideas. And then, yeah, questions in the end. Right. So for the, we'll begin with the background here. And I have many interests in life, and this is not an exhaustive list, but these are some relevant interests that influence this project. So since I started programming, I've done web development that is, started with PHP and all that, and it's been with me ever since that, and still is in like most of the projects or work that I do. It's somehow related to the web. So that's an interest, and it's also like the huge scale of everything using the web. So I find that by having an impact in this area, it's very motivating. And one such impact might be to improve browser testing in some way. And I think that it seems like most of the browser testing tools are based on scenarios and examples. So I wanted to see a bit what could be done there. And in the last few years, I've been digging more and more into property-based testing. I've used it a lot in my own projects and at work and so on. Also written a bunch of blog posts and articles and a short book on property-based testing and how I used it in a screencast video editor to test that. And in that exploration, I've also tried out state machine testing, which can be used for testing user interfaces or APIs or whatever stateful system. And that seems like a relevant thing if you want to test a web application. But if you use state machine property-based tests as they come in some forms, you might end up doing quite a lot of work and boilerplate just to get something up and running. And more crucially, I think, is that these usually build on that you write a model of your system, like a full, complete functional model of how your system is supposed to work. And that means that your model sort of inherits all the essential complexity of the system under test, which might be fine, but might also be not so good. So imagine, for instance, that you're testing a key value store. what we say, like the essential complexity of that is pretty low. Like a key value store conceptually is pretty simple, I guess, depending on its features, but its implementation might be much more complicated if it's a distributed system and you have replication and sharding and whatnot. But the test can be pretty simple still. But if you're testing something that is, very complicated, like say a tax calculation system for I don't know, Germany or something, then you might have tests that are, or a model that is very complicated if it's supposed to test that. So it depends a bit on your system. And yeah, further, I've been digging into formal methods as a sort of rookie, and been looking at tools like F-star and TLA plus and temporal logics and so on. And these all sort of fused together in my mind earlier this year, and led me to sort of try to mash them up into something. And this is sort of where what I came up with. So I started thinking about a specification language, which would be sort of the combination of linear temporal logic and some sort of functional expression-oriented language, which you could use to describe or express how these web applications or systems with web interfaces, how they change state over time. And the state would be something that you get from querying the DOM. That was my first idea, and this is sort of where the language of TLA plus started influencing me a bit. And the neat thing about the DOM and browser testing is that you can interact with the DOM and you can introspect it. So the tool itself could, it could explore your application for you by finding out which actions were possible and so on. This was the idea, at least. And I find that this sort of shaves off a large part of the maintenance aspect of these kind of tests or specifications, because you don't have to like couple your tests or your specifications to the implementation as much, because you don't have to describe all the actions explicitly. And this is sort of piggybacking on that the user can interact with the system through the browser, then a machine should be able to do the same. And in the end, this is meant to run as property-based tests, basically. You could think of this as a special case of property-based testing, really. All right. And some high-level goals of this project is that you, as a tester, should focus mostly on, like, at a high level, specifying and understanding these systems through these specifications. So you shouldn't have to deal with a lot of low level or whatever complex detail. That's a sort of fluffy goal, but something that I want to have in mind. And one more concrete instance of that is that you shouldn't have to deal with timing. So you shouldn't have to insert stuff like sleeping before you take an action, because you kind of know that 1 second after whatever, then it's safe to do whatever. So no sleeps or waits are supported in these specifications, and the tool is meant to deal with that for you. You're supposed to declaratively express the correctness of the system. And also, you should be able to write so-called partial specifications, or I got a suggestion for a term yesterday, which was smoke specs, which was a nice term. But basically, you should be able to say very loose requirements about your web pages and not have to specify all the detail or all the complexity of them. And one nice sort of reusable specification like that might be, say that you have modal dialogues, the ones that pop up in front of something else. You might say that at any point in time in the system, there should be 0 or 1 modal dialogue visible, and there can't be multiple dialogues. And this is more like a UX guideline or some sort of general constraint It doesn't say anything about the functionality of the system otherwise, but that is still a specification. Oh, and on the non-goal side, one thing that I'm not trying to do here is to sort of enforce or automatically do deterministic testing, which is rather tricky. This is interacting with the browser with some system, and it might be deterministic, it might not be, and that is very much up to each system under test. So this means that shrinking cannot be, it's not always useful, because shrinking sort of breaks down when it's non-deterministic. Also, I intend not to support any specific web frameworks or technologies, because not only because I don't want to maintain that code, but I think like a web application should be explicit enough for you to, in a specification, say that, okay, we're in a successful state, we're in an error state, we're currently loading some data or something. If it's not possible to do those sort of queries and see those states, I think then it's probably quite hard to use that web application as a user too. So it sort of goes hand in hand, that if it's usable and it's clear what's going on, then you should be able to test it. So people have asked, like, can we hook into the React virtual DOM or this or that framework? It's explicitly not supported. Okay, before we go on, I'm just going to show quickly sort of how it works at a high level, so you get a sense of what's going on. And it begins by navigating to the origin page, which is called, which is where it starts. It can navigate to other pages, clicking links and so on, but this is where it starts. And then it begins the main part, which is recording a trace. And a trace is a sequence or a list of states and actions. So states that have been seen and actions that have been taken. And when it records this trace, it begins by generating some random actions. And then it picks one of those that are possible to perform at this particular time. And it performs that one, records it. Then it also records the state that it sees afterwards. And then, yeah, it loops until it's, until some bound, or when nothing, it can't make any more progress. Then it checks that the behavior, which is, if you just pick out the states from the trace, you have the behavior. If that behavior satisfies your specification that you expressed with the linear temporal logic and so on. And if not, it might try to shrink it then if you have shrinking enabled. And then it can find a smaller, possibly then find a smaller sequence of actions that triggers an error. So this is very much like property-based testing here. All right, I'll go into the case study now. So I did a case study on TodoMVC, and TodoMVC is a, I don't know, 10-year-old, something like that, project, which basically it was a showcase for various web frameworks for building like single-page apps and so on. So they built the same app, to-do list, multiple times in various combinations of technologies. And so I used all these examples as a sort of benchmark for Quickstrom itself. And in the beginning, I wrote this single specification for it basically has a new and an old format, TodoMVC. So there's the spec, and I checked the mainstream implementations. That's the first bunch of them at the website. You can go to todomvc.com, I think it is. And I found some issues in 2 implementations, the Angular and Mithril implementations, and submitted an issue to this project. And this was very motivating. So I continued on this track and eventually improved the specification to cover more features of TodoMVC. And this was an iterative process because there is no like really rigid complete specification for TodoMVC. There is a plain text document describing the features that you should implement and so on, but it's rather loose in some around some features. But I checked all the implementations and sort of inferred one specification that worked for most of them. And the results were 37 applications passing, 12 failing with various problems. Some you might just consider like a missing feature is a problem, or some other technicality that made it hard to test. But some had what you might actually decide is a bug. And 4 of them were not testable at all, maybe taken down or something. And there's a blog post on the details of this case study on my website. So this is a link in the slides, but I'll share the slides later if you want to follow these links. Otherwise, you can go to my webpage if you can find it. Yeah, so let's go into a bit more detail, and we'll start with the specification language. And I'll show you the current version, which it's based on PureScript. And PureScript is a statically typed, functional, and pure language, which originally started with targeting JavaScript, compiling to JavaScript, and running therefore on Node and the browser and so on. Since then, it's gained a few other backends, I think Erlang and C++ and so on. But this use is a little different. So first off, I've extended PureScript with new operators for doing the linear temporal logic stuff, and also for querying the DOM. So these are special operators that are now available in this language. There is also one thing I haven't noted here, and it's quite drastically changing the semantics of the evaluation. PureScript is normally strict, but now it's lazy, which is a sort of experimental thing, but it enables some fun things to be done with control flow. Using PureScript like this makes it possible without too much effort to reuse the regular community PureScript packages with some work. And this is made possible by this interpreter that I built in Haskell inside Quickstrom for evaluating PureScript in this special way that is required with the logic, the temporal logic operators. All right, and those operators essentially change the modality of whatever sub-expression they accept. So there are 3 operators currently, if I recall correctly, and they are next, always, and until. If you look at next, for instance, it takes an expression of some type A and returns an A. And this essentially takes an expression and evaluates it in the next state. So you can think of it as, changing the point in time in where it's evaluated. And then there are the always and until. They always takes an expression of type Boolean and returns true if that is always true in all subsequent states. And until says that the first expression must be true until the second one is true. For querying the DOM, there are 2 operators. One is called query1 and the other is queryAll. These are pretty much the same as, let's see what they're called in the browser. It's query selector and query selector all. They take as argument a CSS selector with the same kind of thing as you do in the browser. And they also take a record of element state specifiers. And an element in the browser has a lot of attributes and properties and so on. And in this case, you have to explicitly say that, you know, I wanna access particular attributes or CSS styles or whatever you wanna use in your spec. Okay, so for some examples on this, because it's a bit abstract, here is one query all, and I pass the selector button, so I will get all the buttons. And then I pass two specifiers, text content and disabled. And just below, you'll see the type of this expression. So I get back an array of records where each record has a text content string and a disabled Boolean. And in the second example, I do query one, and then I get back a maybe of a record instead. So this is how you would interact with the web page that you're testing, or the pages. And you can pull out state from certain parts of the page. Then in your spec, you also need to specify what's called actions. So Quickstrom currently doesn't do like all random actions. You can constrain the list of actions that it can take. So you pass in a list, which is a list of tuples, where the first element is an integer, which is like a relative probability. And the second one is the action specifier itself. So an array of tuples. And there's a bunch of predefined ones. So you can pass in like just click everything or try to focus anything or stuff like that. But you can also sort of tweak these. And in practice, you might have to tweak these because you have a limited amount of time for running these tests, and you want them to be effective and to have a decent coverage. So you don't want them to spin around doing useless stuff. Also, you might want to constrain and say that you just want to click around and do stuff in this particular part of the web application, not everything. Okay, the specification sort of always looks kind of like this. So you have a PureScript module. Here it's called spec. And you import Quickstrom, and then you say ready when, which is like when this selector is matching any element, then we can start testing. And you pass it some actions. Here I'm just using clicks. And then for the important part, which is the proposition, this is like the safety property. Here you pass in the specification itself, really. And you usually have, if you do a state machine kind of spec, then you have this initial state predicate, and then you say always it's going to be either that transition or the other, or so on. So you have a bunch of transitions. And this essentially expresses a state machine. And the transitions usually look sort of like this. This is simplified, but you say that something should equal foo in this state. And in the next state, something should equal bar. So if this this expression something might build on a DOM query in the end, but this transition would say we're transitioning from something being foo to something being bar. Okay, and by this being PureScript, you can reuse some known packages like numbers and strings and arrays, so on. And this is useful because you can do regex matching and various operations. If you're really fancy, you can use like monad transformers and go wild. These packages usually have some amount of FFI in them, which is normally JavaScript for PureScript. But in this case, I've implemented the FFI or the foreign functions in Haskell. And they're sort of built into Quickstrom, so it's a bit hard to add these packages, but it can be done. And when you want to check the web apps with Quickstrom, you use the check command. You pass a spec file, and you pass some origin URI that you want to start at, which can also be like just a file. And if something a test fails, if it doesn't need shrinking, depends, but you'll get some output sort of like this. So you see the trace with the states and all the queried elements and what values they had at each state. and also the actions in between. This is a bit rough, but this is what you have for now. And here you might see that, okay, there are two, not a number printed in the end there, so it's probably not good. Right. You can use Quickstrom on multiple browsers, currently Firefox or Chromium. It should be possible to support any WebDriver. It's using WebDriver, so any WebDriver sort of server should work. And finally, I want to talk a bit about a concept that I call trailing state changes, which is a sort of complexity that arose from this kind of testing. So you can't really know when state changes. You know, generically, Quickstrom can't know how many times or when state changes appear. But by default, it just records a single state after each action it takes. But you can also override this to say that it should record a number of trailing state changes. And these are, say that you have an action and then you have a state, and then you might have more state changes subsequent to that, that first state. This is often the case when you have asynchronous operations like a fetch or some sort of XHR request. So let's say you have an application where you click a button, launch the missiles, and you see a little spinner saying, missiles on their way. By the way, it feels weird to talk about launching missiles these days, but anyway. And then in the end, you have the last state change, which says, something failed. They blew up in the atmosphere or something. And you just had one action, clicking the button, but you had multiple state changes afterwards, one immediate and one sort of delayed. And you can instruct Quickstrom to await those and observe those with a bunch of command line options, basically. And it uses some fancy tricks to observe the DOM and react immediately. So it doesn't have to be super slow. Right. For the future, I want to probably improve the specification language. So it's using PureScript now, but it's sort of not the greatest fit in the end, I think. It was a very good start because I could get a very capable language early on. But probably I'm gonna switch to some sort of bespoke language in the end. And I'm working together with Liam O'Connor right now on seeing what that might be. Also want to work on better reporting of errors and failures. So the list you saw before with the trace, it's pretty basic and it's hard to go through. It would be nice with some nicer HTML reports or something. I also want to work on coverage so that you can be sure that your specification is exhausted in some sense, that you're just not hitting one case and not the other case. And related to that, it would be nice to combine this with some sort of targeted search. So right now it's just randomly picking actions, but if you could have targeted selection of actions to increase coverage or some other metric, that would be cool. And stuff like screenshotting and so on could be added. And I might want to work on a commercial product for it as well. So keep this CLI version open, open source and free, and then build some service on top of it where we can do everything in the browser, you can schedule stuff and integrate with GitHub and CI and so on. So that might come in the end. And if you're interested in learning more about Quickstrom, you can just ask me wherever you find me, or check out the website, or sign up to the newsletter I post occasionally. And yeah, with that, I want to say thank you for listening, and I'll take questions.
Yeah, thank you, Oskar. So we have 3 questions posted on Hua. So the question number 1 would be, which products are your nearest competitors and where is Quickstrom better? Enjoying the talk, by the way, and like the concept.
Okay, yeah, this is where it'll shine through how much I'm failing in my sort of market research, I guess. I'm looking at this sort of half academically, but I think there is one sort of AI, if you will, kind of testing project. I can't remember the name, but they sort of do some machine learning AI thingy for browser testing. That might be a competitor, even if it's not like the same concept. Otherwise, I mean, the more established kind of scenario-based browser testing tools, where you build the scenarios yourself or you record them through, just using web browser or something like that, they're much more polished and sort of productized. So I guess they are very worthy competitors in that sense, but they're not doing the same thing. So I don't know of anything doing exactly the same thing or very close to this, but yeah.
Okay, one more question from myself. I guess this builds on Selenium or similar. And how do you hide waiting for a DOM object to become available, or do you express it in some other way?
Yeah, so this is built on top of WebDriver, which is sort of a lower level protocol. I think they extracted it from Selenium at some point. And so it's more like an open standard or protocol these days, but basically Selenium, yes. And the Quickstrom does a static analysis pass on your specification to see what selectors and attributes and properties and so on you query for, and then it observes all those in the DOM when it runs. So it sort of reacts to stage changes in your application instead of doing some sort of polling or like that. So you don't have to do any waiting. It sort of reacts to all the state changes and records them. Yeah. Does that answer your question?
Yeah. Well, you will need to visit the app then later and post the shorter answer to the session QA. Yeah. There's one more question and one more after this if we have time. So the question is, I wonder in which cases it might be better to turn shrinking off. I thought of it as an essential part of property-based testing. Are there cases where shrinking is not possible? And can shrinking hide bugs one would have found without shrinking?
Yeah, so the thing with shrinking is that you essentially try to rerun the test with a slightly smaller input, right? And the input in this case is a list of actions. But if the system you're testing is non-deterministic, rerunning, even with the exact same input, might not produce the same result. And then you might you might have one bug exposed in your original list of actions, and then you shrink it, and then it might disappear, or you might get another bug or something. And it starts getting confusing. You might not hide bugs with it, but I think troubleshooting and rerunning tests will be a lot more confusing and impractical. So I know, for instance, that the testing tool Jepsen doesn't do shrinking for this reason, because it's basically they're assuming the systems that it tests are non-deterministic and have, it might be dependent on timing of operations and the network and so on. So basically, I think they've said that we're not doing shrinking in this context. And with Quickstrom, I think you could have it as an optional thing. Right now, it's sort of enabled by default, but you can set number of shrinks to 0 if you want. But it might be an opt-in sort of thing instead.
All right, and I think we have a minute for another question. Okay. Might it make sense to visualize the state change graph?
Yes, that would be a lovely thing to explore. So there's basically nothing else than this ugly list that I print in the terminal, but it would be nice to do either try to sort of build something like a state machine representation, if you will, but then you would need to identify multiple states as a logical state with different values. So it might be tricky to do automatically. I haven't really even tried doing that or explored that, but it would be interesting to get like a state machine diagram out of these tests and being able to troubleshoot in terms of that representation and so on. Otherwise, it's mostly like screenshotting and stuff like that I've been thinking about. But if that could be, if that could be somehow inferred from the run, that would be very cool.